Hi guys, this is the last section of the chapter 3 exponential function. I slightly modified it. It was supposed to be exploring the exponential function. However, this is more realistic in terms of doing the question. So I modified it. So it is now exponential growth and decay. This is the real life application of exponential functions, how it is used. It's usually used to predict numbers, okay? So if you take a look at it, you have to remember two equations, or two formulas to be exact, or to be precise. The two equations are this and then that. Oh, by the way, I'm recording this at a school, so time to time you will hear people's voice coming from a hallway, okay? Now, then, if you look at this, we have y equals a bracket 1 plus b bracket to the power of t over n, and then the other one is minus instead of plus. Now, as I listed up here, a represents the initial value, okay? It is the initial value. Y is the final. Now, then b, it says factor of growth or decay. It means that how much it's decreasing or increasing by, okay? If it says it increases by 50%, then the b is a 0.5 because 50% is 0.5, right? If you're not sure how to convert the percentage into a regular decimal, you basically divide it by 100. That's all that is. And then the t is how much time it takes total, and then n represents how long it takes to increase or decrease every time, okay? So let's take a look at the first example. Now, before that, one thing that I have to make sure is this. If you have 1 plus b, so what's inside of the bracket? If that is greater than 1, so for example, like here, 1.5, then it is growth, because every time your value increases by whatever that much. On the other hand, if you have less than 1, so for example, in this case is 0.3, then it means that you're decreasing because every time your value becomes 0.3 of what's previous of, okay? So if you take a look at the first example, the world's population doubles every 35 years. So if it doubles, it means that it increases by 100%. If you're not sure about it, now 1 to 2, it doubles, right? Now the increase was by plus 1. Now then plus 1 is basically the same as the initial value. So it increased by the initial value itself, meaning 100% of the initial value, right? If you're confused with that one, I will say then what about 2 to 4? So from 2 to 4, I have to increase by 2, but 2 is the initial value. So it increased by the initial value itself, so it's increasing by 100%, okay? Now then, all you have to do is use the formula. Now obviously it says double, so it's a growth, right? So we have y equals a 1 plus b t over n. Now all you have to do now is just putting the numbers in. So in this case, it doubles every 35 years, so your 35 should be n. Now then it says 6.5 billion is your starting, so initial, so that is your a. And it says how much is or how much is the population in 70 years, so that's the t. So all you have is y equals 6.5 billion. I'm not going to put all those zeros. Then 1 plus 1, then 70 over 35. Now you just need to use a calculator to do this. So this is 6.5 billion, 2 to the power of 2, which is 2 squared. So that gives me 6.5 billion times 4, so that is 26 billion. So therefore, so that there's got to be a therefore statement since this is a word problem. The population, or it will be a 26 billion people. Okay. Now in the examples, I'm going to omit the therefore statements in order to save time. But on the test, I really want you to put the therefore statement as a part of your answer. Okay, it will be marked. Now here, the number 2, an investment of $1,500. So A, right? You invested $1,500 initial value. Now increased by, so we know that this is a growth because it says increase. Increased by 2% every 3 months. So your B is positive 0.02 since it's a 2% every 3 months. So it means, let's say your N is 3 in months. Then your t, it says, what is the value after 5 years? But it's not in months, so we have to convert that. So this is in months. I'll just put it. Now this is 5 years, which is in months, 60 months. Then you're looking for the y, the final value. So all you have to do is just plug the numbers in. So 1500, 1 plus 0.02. And then we have t as the 60, n as the 3. Now, then this becomes 1500 and then 1.02 to the power of 20. Using your calculator, you should be getting, a big number in this case. So 1500, I'm putting the numbers in my calculator right now, to the power of 20. That should give you 2228.92. Now, since this is a money problem, you should have therefore 2228.92 is the final amount, etc. Now you will probably ask me, to what decimal places do I have to round up? I usually take about 2. Okay, 2 decimal places, this should be fine. Now number 3, then the number of popular cafes in Toronto has been growing by 8% every year. So from the first sentence, we know that the b is plus 0.08 because it's growing. Now, if there are 400 cafes right now, so that means that my A is 400, and then how many cafes in 10 years? So it is 10. Oh, I forgot. The N is 1 because it says every year. So all you have to do is y equals then 400, 1 plus 0.08 to the power of 10 over 1. Now, using your calculator, then this becomes 0.08 to the power of 10, and this then becomes, I have to put all the numbers into my calculator all the time, every time, so there may be a little pause to it, okay. Now this then becomes 863.57. Now we can't really say 57 cafes, right? So we are going to round down in this case, okay? So whenever there's gotta be a whole number as the answer, you are going to round down. One example that we cannot, the reason why we cannot round up is, for example, I can say how many people are there. I cannot say 0.5 people. Like we can't really say, oh, there's a head. We can call the head as a 0.2 person. So always round down. So when you have therefore, you say 863 cafes in Toronto. Okay. Obviously, you have to put a full sentence. I'm just putting a shorter one since this is an example. Okay. So then let's get to the next sheet or next page. So it's the same thing over and over. Now the number of ants at Bob's house, hopefully that doesn't happen to you, but time to time it happens. So ants at Bob's house triples every 40 days. Oh gosh, every 40 days it triples. Now it means that your, let's say, 1 ant becomes 3 ants, so meaning you increase by 2. So increase by 2 is twice as much as the initial, so your B is then 200%, or we can say just a 2. Okay. Now if there are 24,000, so A is then 24,000, and N says 40 days, so I'll say 40 days. I will put the unit so that I don't get confused. And then T says 90 days, so it will be 90 days. Now make sure the units of N and T are the same, okay? They have to be the same. So Y equals then 24000, 1 plus 2, then 90 over 40. And all we have to do is just to calculate this. So I'm just going to calculate this. Now this then gives me 24000, and then that to the power of that gives me 28427 well, that's actually 1.986-ish, but I will just 284,272. I will round it to the whole number because you have 1.986. You round it, it becomes the whole number anyway. So then therefore there are 284,272 ants after 90 days. Now number 5. Now number 5 says half-life. Now one note that you have to make, if it says half-life, it means your initial value decreases by half every time. So it's the decay, obviously. Therefore, your B is negative 0.5. Okay. And then it says in every 3 hours, so N is 3 hours. Now, if there is initially 12 milligrams, so there's 12, how much will remain after 1 day? So T, it says 1 day, right? It says 1 day. 1 day. But we know that 1 day is basically 24 hours. So your Y equals 12. Then 1 minus 0.5. Remember, this is a decay formula, so it's negative 0.5. And then 24 over, where am I? 3. There you go. So it is 12 and then 0.5 to the power of 8. And that, using your calculator, should be very, very small number. Times 0.5 to the power of 8. Oops. So again, 12 times 0.5 to the power of 8. Now this then gives you 0.046875 milligrams. So again, there's got to be a therefore. Okay. Now, number 6, a piece of ice shrinks to 20%. Now, this is an important question, so I want you to put a little star mark on the side. This is an important question. So far, the question was telling you that something is increasing by or decreasing by, but this one actually is shrinks or decreased to. So, for example, if you had 100, now this one decreased to 20. It means that it's decreased by 80, right? So your B value is negative 0.8 in this case because it decreases by 80% so that it becomes 20%, right? Now then every 6 minutes, so every 6 minutes, now it weighs 4 kilograms now, and then how much will it be after or in 15 minutes? So then Y equals 1 minus 0.8. Obviously, there is a 4 in the front. Then 15 over 6. Now, then this becomes 4, 0.2, 15 over 6. And that, using the calculator, this should be now 4, 0.2, power of 15 divided by 6. That gives me 0.0716. It was 0.07155, but I just rounded. So 0.0716 kilogram is left. Therefore, that's it. Okay, so hopefully this was easy enough. This is how we do the growth and decay projection. This is actually used in the lab and here and there. Obviously, the model that they use is a lot more complicated, but the basic idea is this. So I'll see you guys in class. Now, this one is not in the textbook, so I uploaded the extra worksheet questions that you can do on the website. So please go and then print and download, and download and print, not print and download. Download and print and bring it to the class. Okay? All right. See you in class. Bye, guys.